Good day, everybody, and we meet yet again. Right, so today I wanted to just look at questions that have to do with electrical circuits and particularly looking at graphs. So please, if you haven't subscribed, please do the right thing and welcome to the family if you've just subscribed. By the way, it's for those of you who still need help with tutoring. Okay, my email address is info@mlungisinkosi.co.za. Please, you can arrange some lessons there and we can see how to best help you. Now, quickly, let's go into this question from the 2016 prelim exam. Okay, I thought I should just go through this question because it initially gave me just a bit of a headache, and I'm sure that if I could get a headache from a question, it might obviously become a bit challenging for you as well. So I just want to share some nuggets of wisdom on how to tackle it. Okay, so it's this particular question. We'll come back to this one sometime later. Now, they say a learner sets up a circuit shown below to measure the internal resistance of a battery. Now, this is the type of circuit that they set up. Now, the rest of the question is, however, on the next page, which we are going to open up now. Okay, so in this case, she records the reading of the voltmeter for the different resistance of the rheostat. So the graph below is obtained from the results, and that's the graph that you get there. Now, I want you to please note the graph that we have there is a graph of the inverse of current against the external resistance of a circuit, right? So how would we go about answering that question? Okay, all right, so first of all, they said define the term EMF. Just please remember that's the total energy per unit charge, all right, across the terminals of the battery, okay, or of a cell. So in this case, for 11.2, they say calculate the gradient of the above graph. So what we're going to do, let's just choose any of the 2 points there, okay, and try to calculate that gradient. So let's do that first, okay. So I'm going to say, let's take any 2 points. Let's take that point over there. If you'll notice on the time axis, they increase in twos, and please remember how you now obtain them, or how you get the scale of it, okay, the smaller scale. All you simply do, remember there are 10 subdivisions, okay, in between. So I'm going to say 2 minus 0 divided by 10, so that's 0.2. So that increments by 0.2. So I want you to please note this is at 8, okay? So to look at that increment, I just want to take something smaller that would kind of help me, okay? All right, so you can see that that increment over there is 8 point, okay, that's going to be 8.268. So that's 9. Actually, that's 9. So that value there is at 9. And in terms of 1 over current, the increment there, that would be, okay, so this would increment at 0.1. So we'll say 1 minus 0 divided by 10. So that would be an increment of 0.1. Can you see that? Okay, so in this case, this is 3 okay, that's 2 points away from 4, so that should be 3.8. okay, so I'm taking that point over there. All right, so one of my points, so let's write it there. So that point over there, okay, is going to be, let's take, the first point is going to be, okay, so we said it's going to be 8, or rather, and 9 on the x-axis, right? So this is going to be 9, and our next point is going to be 3.8, we said, right? Okay, now please remember, this is the resistance value. Okay, sorry, that's the resistance value, and that is actually 1 over current, which is that value over there. Remember? So this is 1 over I. So that's the X and that's the Y value. Okay, right. So sorry, I just need to make that adjustment a little bit. Okay, so that's the resistance value, and that's 1 over current. That's 8 ohms. And then all I'll simply do, let's just make it simpler for ourselves. Our next point, this would be at when X is 0, which is resistance, is 0, and that Y value, which is 1 over current, that would be 0 0.1, 2, 3, 4, and 5. So that would be 0 0.5. Okay, so remember, how do you calculate gradient? Okay, all the time when we take gradient, we're going to say the change in y. Okay, so I'm going to say change in y divided by change in x. But in this case, what's our y? It's going to be 1 over current. Okay, so that's change in 1 over current. Okay, divided by the change in resistance. Okay, so that's change in external resistance. Okay, so in this case, I'm going to simply say, all right, let's take our y values. So this is going to be 3.8, so y2 minus y1. Okay, 3.8 minus 0 0.5. Okay, divided by, okay, when x was, or rather when y was 3.8, what was our x value? It's 9. Okay, so that would be 9 minus 0. Okay, so now we're going to calculate that quickly. Okay, I get that value to be 0.37. You can confirm for me. Okay, so that's the value that I got, 0.36666667. So I'm just going to round it off. Now, this is the value of our gradient, right? So let's just keep it, it's going to be amperes. Remember, it was per ampere, and in this case, ohms, right? So in this case, it's going to be ampere minus ohms, okay? Or rather, per ohm. All right, now, of course, it's not really important that you keep that SI unit there. They just wanted to find the gradient. Now, then they ask us the question, okay, what is represented by the gradient of the graph in 11.2? Now, I want to take you through the thinking behind this question. You've got a graph here that has to do with 1 over current and 1 over, against the external resistance. And remember what they wanted to investigate. They wanted to investigate the internal resistance of a battery, isn't it? Okay, so now, how do we relate the internal resistance of a battery? If we go back to that equation where we've got EMF, which is equals to I into R plus small r, okay? So remember we said this is R external, and this would be the internal resistance, and of course that represents the EMF of the battery, okay, and or the cell, all right, and that's the current. Now, if we were to try and arrange this a little bit around, because we want to have 1 over current as our subject of the formula, okay? So in this case, so I'm going to take my current, okay, so I'm going to say, all right, let's try and rearrange this formula. So what I end up having, if I divide both sides by R plus small r, okay, so I'll do the same on that side. So that's R plus small r, okay, so that we cancel that, okay. So now what do you have? You've got current here, all right. I'm just going to put it on this side, on the left hand side. Current is equals to E over, okay, R plus small r. Now, I want you to please note. So remember, if I were to write that down mathematically, this is the same as saying I over 1, okay? So how can I actually make this, in such a way that it will actually become the inverse of current. So all I'll simply do, ladies and gents, is that I will just invert that, okay? But what I do on the left, so I now have 1 over I, which will be equal to R plus small r, which is our external resistance, internal resistance, divided by E, okay? Right, now this is the equation that I end up having, okay? Right, I'm just going to continue over the other side. Now what happens? Remember, if I just write this in another way, okay, well, not exactly in another way, just expressing it such that we've got internal resistance as a subject there, okay? I'm just going to continue over the other side. All right, so I have got internal resistance as my subject. Okay, so there's my formula over there. Okay, I'm just going to continue there. So in this case, I've got 1 over I rather, okay, which is equal to, now, please note, I'm going to write that as 1 over E into R plus small r. Can you see that? So if you think about a normal straight line graph rather, okay, so usually you would have something like y is equals to mx plus c. All right, so you can take that as 1 over E times R, okay, so this would be your gradient, okay, plus 1 over E times small r, okay. Now in this case, we've got 1 over current making that. Now, please, I want you to note. So if you think of this as a straight line graph, mx plus c. So it means now what represents your gradient? Your gradient would be 1 over E. Can you see that? Because now your independent variable, usually that would be x. Okay, so that would be on the x-axis. So on this graph, what's on the what's on your x-axis? It's the external resistance, which is this guy over here. All right, so meaning that would be your constant. All right, I hope you can see that, or you can follow what I'm saying. So in this case, 1 over current, that's your y, okay, and your m, in this case it's 1 over E. So they asked us the question, what is represented by the gradient of the question in 11.2. So the gradient represents the inverse of the EMF. Okay, so it means that okay, of course they're not asking us to calculate it, but look at the next question. The next question says use the information on the graph to calculate the EMF of the battery. Right, so now to get the EMF, so now we're going to 11.4. So to get that EMF, we are now going to say, well, M is equals to 1 over E. But remember, what did we get for our value for M? We got 0.37, isn't it? Okay, so I am simply going to say, well, this is going to be 0.37, okay, and we want the EMF. In fact, yeah, I'm hoping my value is still there. So we want the EMF. So all that we simply do to get the EMF, we are just going to take the inverse of that. Okay, so remember this is the same as 0.37 over 1, right? So in this case, I want E. So I'm going to say, well, let's get E. So I'm inverting that. So it means I must also invert. Okay, so I'm just going to go to my calculator and say, take the inverse, okay, of the answer. And I get 30 over 11. Okay, if you want it in decimal form, it's 2.72. Okay, so it means that my EMF is going to be 30 over 11. Okay, and remember that's in volts. Okay, right, so E is 30 over 11 volts. I hope you can understand what we've just done there, right? Okay, so now we get to the last part of the question. All right, it was really quite an interesting question. So they say to us, calculate the internal resistance of the battery. Now that's going to be quite simple now that we know what we know. Okay. If you don't mind, I'm just going to do it to answer that question over here. Okay. So now we want to find out what would be the internal resistance. But now we've got that equation over there, right? And not only do we have that equation, but we also know what the gradient is. So it means 1 over I, okay, is equals to 1 over E. But remember, we know what is our gradient. We said our gradient is 11. It was 11 over 30 actually. 0.37, that 0.366667. So that's the same as saying just 11 over 30. Okay, remember that's why we got 30 over 11. You can say this is 2.72 if you want to. 2.72 volts. Okay, so that's going to be 11 over 2 multiplied by R. Okay, in fact, let me rather take the simplified form, this one over here. Okay, so it's 11 over 30 R, okay, plus that small r over there. Okay, now all that I need to do is just get 1 point from the graph, substitute it for the 1 over current value as well. Now I'm going to choose a point. Let's take any point on our graph. Okay, let's take the point there. Okay, so this is where x is 2.2. Okay, and our y would be, let's see, that's 1 2 3, so that would be 1.3. Okay, so 1 over current. All right, this 1 over current, our y is 1.3. So I'm substituting the point. X is 2.1. In fact, let me show that. So where x is 2.1, okay, and y is 1.3, and I'm substituting it into that equation. So 1 over I, we said that's our y, which is 1.3 rather. So that's 1.3 is equals to 11 over 30, our gradient, okay, or that 0.37, okay, multiplied into, now when the current was 1.3, 1 over current was 1.3, the resistance is 2.1. So I'm going to substitute that there, and then plus the internal resistance. Okay, really, I hope you are following onto what we are doing in this question. Really an interesting question. I'm sure some of you have done that in your practicals. So all that's left for us to do is to just take the gymnastics there, right? Okay, so I'm going to say, so if we take those gymnastics over there, so I'm going to divide by, or you can multiply by 11 over 30, or 30 over 11 rather. So what you do on the left, you would do on the right. Okay, so you can say just divide by 11 over 30 here, so that this divides, cancels that. So divide by 11 over 30, okay, and you get a value there. And then whatever value you get over that side, you subtract 2.1, and that would give you an R value of 1.45 ohms. Okay, and essentially that is how the cookie crumbles, ladies and gents. I hope you really understood that question. All right, and by the way, it's a very important cognitive skill that we try to teach you. Okay, that you need to be able to interpret graphs. Okay, we need to be able to read off from a graph. That's a very important skill. First of all, you must be able to tell what the scale of the graph is. And please remember, the graphs that we give you, if it's the accurate graph, okay, usually there's about 10 subdivisions in between. So all you simply do is just to take the difference between the main divisions, okay, the main partitions of the graph, and you divide that by 10. So that's why I knew that this is actually increasing in 0.2s. Why? Because 2 minus 0 divided by 10, that will be 0.2, okay? And for that one, it's 0 minus 1 minus 0, which is 1, and then divide that by 10, that will be 0.1. So I hope that you got the gist of it, all right, and hopefully you will ace it. Okay, so please just remember to subscribe for those of you who haven't subscribed, and I'll see you guys next time. Sharp, sharp.